This video demonstrates why eigenvectors corresponding to distinct eigenvalues of Hermitian matrices are always orthogonal. Consider a Hermitian matrix named matrix A. Suppose matrix A has two eigenvectors, named vector v1 and vector v2, corresponding to eigenvalues lambda 1 and lambda 2. This means matrix A multiplied by vector v1 is equal to lambda 1 multiplied by vector v1. And matrix A multiplied by vector v2 is equal to lambda 2 multiplied by vector v2. To establish orthogonality, take the inner product of vector v2 with matrix A multiplied by vector v1. This can be written as vector v2 conjugate transpose multiplied by matrix A multiplied by vector v1. Using the eigenvector equation for vector v1, substitute matrix A multiplied by vector v1 with lambda 1 multiplied by vector v1. The expression becomes vector v2 conjugate transpose multiplied by lambda 1 multiplied by vector v1. Since lambda 1 is a scalar, it can be factored out. This simplifies the expression to lambda 1 multiplied by the inner product of vector v2 and vector v1. Since matrix A is Hermitian, it follows that vector v2 conjugate transpose multiplied by matrix A is equal to the conjugate transpose of matrix A multiplied by vector v2. Matrix A multiplied by vector v2 is equal to lambda 2 multiplied by vector v2. Factoring out the scalar lambda 2, the expression simplifies to lambda 2 multiplied by the inner product of vector v2 and vector v1. Since lambda 1 and lambda 2 are distinct eigenvalues, the inner product of vector v2 and vector v1 must be equal to 0 for this equation to be true. This shows that vector v1 and vector v2 are orthogonal. This proves that for any Hermitian matrix, eigenvectors corresponding to distinct eigenvalues are orthogonal. This property is a fundamental result in linear algebra, ensuring that Hermitian matrices have orthogonal eigenvectors. If you found this video helpful, please like, share, and subscribe to support the channel and stay updated with more informative and engaging content. Thank you so much for watching, and we'll see you in the next video.